Hey guys, we're back, and today we're going to talk about GraphQL, domain graph services, and GraphQL Federation. So let's start off first with talking about why GraphQL exists. And yeah, let me just share my screen for that. All right. So to understand the reason why GraphQL exists, we need to first look at how engineering teams and developers are arranged in a normal company. So for that, we'll first have to talk about how basically an engineering department is built. So to start off, you might have maybe 2 engineers. This is a front-end engineer. So at the start, you might have a full stack engineer who does everything. He builds your front end, and he comes up with a front end web app, and he comes up with something like maybe a monolith, since it's just one guy working on this. And both of these would be basically connected and talking to each other. So this is basically developer number 1, and he's just
Damien, can you zoom in a bit just to make sure it's clear? All right. Oh yeah.
So this would basically be what it starts off as. So let me just how do you make a frame? Frame, shape, connection, pen, frame. There you go. Okay, sorry. Let's make a frame here. Extend this out. Okay. So this is basically what a startup would look like. You have one engineer who's working on everything. He builds a front-end web app, and you have something like a monolith. As and when you grow, what would happen is you would maybe have a bunch of full stack engineers. So you would have maybe 3 full stack engineers working together on, again, the front end, the monolith, but this time you might actually have something like a little mobile app.
Yeah.
All right, so the mobile app would also still be communicating with your monolith in this case. So so this would be something like startup, sorry.
More like a funded startup.
This would be something like that. So this would be startup stage 2, and so let's call this startup stage 1. And then afterwards, as you go into maybe hypergrowth, or as you start expanding your team, you might come up in a scenario, or you might face a situation where you have actually a bunch of engineers working together. So for example, you would maybe have 4 engineers dedicated for your front end. You might have 2 guys dedicated to your mobile app, and you might have 2 guys dedicated to your backend. So this guy would be a front-end engineer. Same here. This guy would be a mobile engineer. Let's just call them MEs. And then you would have BEs, backend engineers. All right. So these guys, so this guy here, these guys would be looking into the front end specifically. So I think a better way to show this would be Okay, this is like one group of guys, and let's yeah, there's one group of guys. We would have another group of guys here working on these are like basically specific clusters, and then you'd have another bunch of people working on the back end. But in this same scenario, what would happen is basically all of them would still be kind of working on this this sort of code here. All right, so here what you would see is these guys would be basically responsible for this, and I'm going to show this in a zigzag line. And these guys would be responsible for the mobile app, and the backend engineers would be basically responsible for the monolith. Once this happens, this is still a fairly manageable situation. You would probably have maybe a bunch of endpoints in a monolith, and it wouldn't be much of an issue. But as soon as, for example, as you scale up your user activity, as soon as you start to get more seed funding, you might come to a point where, okay, your investors also ask, okay, how far can you scale up the service? How far we need to move this into, more highly scalable infrastructure. You need to break up this monolith, and you need to be able to give responsibility to teams so that they can scale this up and they can develop at their own pace. And for that, what would basically happen is you would be splitting up this monolith into different microservices. So this would be something like startup number 3, and then you would go into microservice architecture. You would jump right into microservice architecture. All right, so what happens here is you would, when we talk about microservices, I'll just do a direct leap here. I'll break the monolith into microservices, and I'll break the front-end web app into microfrontends as well, so that it's much more easier and it'll be faster for us to get to our point. So what we'll do is we'll have a bunch of microservices. So at the start, you have maybe your login service. So let's call this auth. You have a service for people. So people service, and we have, this would be something like still a startup, stage 4. And you would also have, maybe assuming that this is some sort of ordering application, you would have an order service. Instead of people service, I'll call this the user service because that's the normal term that we use. We would have the order service. We would maybe have some sort of service to track payments. So you would have a payment service. You would have some sort of service to track reports. So we call this the report service. So this would basically be your backend. Oh, just a line. Okay. This would be your backend. Then you would have a bunch of micro frontends. This would not be a direct leap from startup number 3 to startup number 4, but somewhere along the line, you would come to something like this. So you would see your login, you would see maybe a front end for maybe dashboard, micro front end. You would see maybe a front end for profile pages, profile micro front end. You might see an ordering micro front end. So somewhere where you can place your order, and maybe another micro front end for just for authentication, auth MFA. And then you would also have your mobile app. All right. So, so here, instead of report service, let's just call this a search service because that makes more sense. If you have an e-commerce platform, you need to be able to search for products. So here, what would happen is if you have backends like this and you have a bunch of front ends like this, the first thing that people tend to do is they tend to directly connect these directly into, so let me just show you what happens. Yeah. So it would look something like this. So the dashboard would connect to the user service. Yeah. It would connect to the order service, maybe to fetch some recent orders. And then it would try to connect to maybe the search service. You need to show some searches somewhere. Yeah. And you would basically be integrating each front end with all of these different services. Same thing would happen for profile. You might want to show the user details. You might want to show your previous orders. You might want to show different stuff like that. So you might want to show your recent payments and all sorts of stuff. So I'll just, I think it makes sense for us to have this messy, because it brings across the point of why exactly we need GraphQL. So the ordering might be linked to payment, and it might be linked to the user service here. So as you can see, slowly and slowly, this entire architecture is getting really messy. So auth microfrontend would be directed to login. It would also need to probably authenticate who the user is. So it would connect to the user service. The mobile app will, since it doesn't have microfrontends, it would probably connect to each and every one of these. All right, so yeah, this is very messy, but this is sort of the point that I want to bring across. All right, you have the payment service. All right, and the mobile app would also consume the search service. All right. So what do you think, Thomas? What do you think about this architecture?
I think it's very.
It looks like shit.
Yeah, it looks like
it looks very bad. So
and it's more like and we can relate to those as well. Like, I mean, it's what's happened when you start off with the microservice and then keep expanding. Yeah,
exactly. So what happens here is you have a team of, so I'll show these guys as you have your backend engineers looking at this side of it. All right, so let's just is there a way to select all of these? Nope. I'll just show, okay, these are the backend engineers. This is what they look at. And then we would have front-end engineers looking into this side of it. And you would have mobile app engineers looking into this guy here, the mobile app. Agree? So
yeah.
Now whenever something happens, whenever say the user service introduces an event point, each and every one of these, depending on who uses it, they'll have to use that, and they'll have to write code to use that endpoint. The mobile app will also have to write that use that endpoint if the user service ever changes its contract. So it changes the architecture of the endpoint. All of these microfrontends will need changes. All of these clients would be blocked, and it would be a big hassle. So to fix something like this, we have a pattern in the industry, and that's called the BFF pattern. So let me just show that to you. So if you have a bunch of stuff like this, so I'll just copy all of these and this, all right. Okay, so if we have something like this, what we would do is we would, instead of directly connecting all of these into these services, what we would do is we would introduce another separate layer here. All right, so I'll just pull this out onto this side. Let me add another divider. All right. And instead of this complex pattern where all of these microservices directly connect, or the clients directly connect to these microservices, they would instead use an intermediary service in the middle here, which does that aggregation for them. So basically, they would make use of something like an orchestration layer. So let me just delete all these. All right. So instead of having that entire hassle, what we would do is we would create a bunch of services depending on who uses them for each of these. All right. So what would happen is this would be a BFF. This would be another BFF. So this is a BFF in the sense this is a backend for front end. So the backend for front end is really a very dumb layer. It normally does not contain a lot of business logic. But what it does is it allows us to connect all of our clients and orchestrate their requests to the backend. So what would happen here is this guy would sort of be like the orchestrator. So in this case, what would happen is, for example, if say the order service changed one of its endpoints, none of these other services, none of these other clients would need to change. If the order service changed its contract, it would only need to be updated in the backend for frontend. Unless it's a very major change, it would only be, you would only need to apply it here. The other advantage is that, for example, say you have the dashboard, and the dashboard needs some sort of data in which you need to aggregate the data across the user service, order service, and the payment service. So for example, in the dashboard, you're showing a widget for the user, for example, me, and it shows my latest orders and the latest amounts that I have ordered for it. So instead of sending out 3 different calls to all of these services, the web backend for frontend can expose a custom endpoint saying, okay, this is what you want, this is what I'll provide. When the dashboard hits that endpoint, the web backend for frontend would execute 3 of those requests, aggregate that data, and send it together in one payload to the dashboard. So that's one of the advantages of BFF. And the other advantage is that you can mask all the requests in the front end. So what I mean by masking is basically if you go into the network tab, that is, if you go into the network tab on any website, instead of seeing requests going out to 10 different services, it would only be going into one service. So it's much more cleaner that way. And the front-end engineers would only need to bother about all the different endpoints in the backend for front-end instead of having to worry about contract changes or differences in all these other microservices. So those are some of the few benefits for backend front-ends. But these are some of the few application level benefits, but then there are a lot of other security benefits as well. So if you talk about security benefits, you could restrict each of these microservices into its own security group. If you're using AWS, you can restrict it to its own security group so that it's not publicly available to the internet, and it's only accessible via this BFF. So you won't be exposing data or leaking data out of any of these microservices. And these dashboards would ideally be linked or would be working only on the public facing engine. So this is basically a very solid pattern that a lot of people use. And again, one of the reasons that they use this is so that it can scale up quite a lot faster. When you go into, okay, so now, as I said here, we have a bunch of engineers, front-end, mobile and backend engineers. Now the issue here is when this grows much more bigger. So say you have an engineering team of about 50 engineers. If you have a web backend for front-end, a single web backend for front-end, this would inadvertently become more like a monolith, because you would have 50 engineers committing code all at once into this single block of infrastructure. In order to avoid that, what we can do is we can break this open into domains. So the next pattern would be the same thing, basically the BFF pattern, but a bit different in the sense that it would, instead of one BFF, you would have a bunch of different BFFs for each domain. So what do I mean by a domain? A domain is something, it's sort of a logical separation of the business requirements of your web application. So as you grow your web app, it will become next to impossible for each engineer to work on everything. So for example, you have 10 engineers. It will not become possible for each and every one of them to work on
know everything.
To know everything and to work on all the services at once. So that's where the domain separation comes in. So this would be the backend for frontend for the profile. This would be the backend for frontend for dashboard. And you would start breaking these up. So another reason why we have domain separation is so that it's easier for us to break all these into teams. And another reason that we do that is there are a lot of reasons for this, but one of the reasons we do that is so that we can maintain agile. We can maintain an agile project. So basically, we have small teams that are self-enabled, and they basically just do all the changes related to business requirements. So you would ideally have a project manager or product owner. You would have a team lead, and you would have a bunch of front-end, back-end, and mobile engineers in every one of those teams. So basically, it would look like one of this would belong to one team. So yeah, so this would belong to one team, same as all the others. So what that allows us is in one way it furthers the Agile manifesto, and in another way what it would do is it would enable us to push features and feature requests, bug fixes, performance improvements, performance tuning into production much more faster, instead of having 50 engineers working together trying to merge requests, resolve conflicts, trying to go into some sort of queue, merge everything into a release branch, and try to deploy it in production. It's going to be hell. And in order to stop that, and in order to manage the organization much more efficiently, we just break everything up into small teams. So this sort of pattern is much more needed once you have, so I would say this is the BFF pattern for large teams. All right, so yeah, you would have the order backend for front end, you would have the auth backend for front end, and you would still have the mobile backend for front end. So you can actually break this down into a much more granular level, and all that depends on what your team actually wants to do. So once you start working for organizations with more than 100 employees, more than 500 employees, it becomes really important that you have this logical separation, and we call this the separation of concern across all of these domain services. So this is really important, and it also enables each of those teams to deploy by themselves, and there are a lot of benefits out there. So this is the BFF pattern for large teams. This comes at a cost though, because what happens here is that once you start maintaining all these backend front ends, you would basically be having a lot of duplicated code in some instances, and you'd also maybe have a lot of, give me a second, yeah, you would have a lot of duplicated code. You would also be having a lot of issues where front-end engineers starting to work on the BFFs, and then they get they need other stuff. You need to you need to do aggregations. You need to do a lot of other stuff that BFFs really are designed for. And another point is that these BFFs are actually services. So each of these BFFs are also sort of microservices. They are scalable and ideally stateless microservices. So each of them would add a certain amount of network latency on top of the entire trace. So if you're requesting for an image from your dashboard, it will go through the BFF. It would add on a bit of latency, and then it will go to the microservice. It will come back, add on latency, and come back to the dashboard. So it's not ideal if you want really fast services, and it's also not ideal if you are looking for a bit of a less maintenance approach for each and every one of our teams. Yeah, so that's for BFFs. So the next point of BFFs is actually this GraphQL server. So let me just, I think GraphQL would look much more better with the original BFF pattern. So let me just copy that on here. And we would have GraphQL.
Damien, let's do a quick intro to GraphQL as well, like before jumping in. As in, like, yeah, I think the backend for front end, like BFF, was very clear. Was like, I mean, like it's all, I mean, crystal clear, I guess, for our viewers as well. If you can give an intro to GraphQL, and then we can move forward. Like why it's good there.
So the reason that we would use GraphQL here is, first I'll explain what GraphQL actually does. All right, give me a second. So in simplicity, what happens is GraphQL basically maintains types. Sorry. This would be something like a GraphQL server. All right. And what this would do is it would maintain, two things. It would maintain types, and it would maintain schemas. All right. So what GraphQL does is it sort of aggregates in a very simple layman's term. It aggregates all the endpoints and all the basic schemas that are exposed through all of these microservices into one sort of into one place. So it's kind of something like what Elasticsearch does. It's not what Elasticsearch does, but it's something like that. So for example, you have thousands of records on Elasticsearch, and you write a query which matches and extracts exactly what you need from maybe different records and just returns that to you. That is something like what GraphQL does. So from the dashboard microfrontend, I say, okay, I need the order data and the payment data for this user in this sort of payload. So I need it in a payload that looks like something like this. Okay, so I need user first name. Yeah, let me just look at that. Okay, so I need user first name. I need his ID, which would be use. So okay, this would be the user object first name, which would be a string. I need an ID, which would be an int. I need his latest orders. So I need orders in an array. All right. Sorry. I need orders in an array. And what each of these would do is this would have something like, okay, the ID of that order, which would again be an int. I would need the name of that order, which would be a string, number of the count, number of items, or maybe the date that it was ordered. So this would be date time. And then again, payment information. All right. So what did this guy pay? So something like method would be credit for credit card. Provider, maybe you can say Visa. So these could also be strings. I'll just write string here. String and amount he paid for, that would be, ideally it would normally be a double. So in order to get this sort of information, Normally, what a micro front end would need to do is, okay, so in order to get a block of code like this or payload like this, what the micro front end would normally need to do is it would need to first go to the user service to get the first name and the ID. It would need to go to the order service to get the relevant orders for that user. And it would need to go to the payment service to get the payment methods and the other related information. What GraphQL will do is, based on the schema and what you're requesting, what GraphQL will do is it will go to each of these relevant services. It will check for these types, okay? So what I mean by types is the string, integer, datetime, double, not datetime, double, and stuff like that. So it would check for those types. It would make sure, okay, this guy is sending us a proper payload. It would aggregate the payload in the way that I want, and it will send it back to me. And that is basically done using these schemas that we define here. All right. So if you want to go deeper into GraphQL, we can, how it exactly happens, how we define types and schemas. But yeah, I don't think we need to go into that level.
Just to add to that, Damien, so I think one of the key, I mean, the advantage would be also like having multiple data sources, let's say. So now it's like API services, and we can have many of those like different types even. So one can be API, one can be even like static file, I guess. So
exactly. Yeah.
It can be any sort of data. So it acts more like a data connector, and while giving all the
aggregators. So yeah, we call them aggregators. So this would act like an aggregator, and what it would do is aggregator, or we can also call them an orchestrator. So it orchestrates all that backend data. It constructs it into whatever payload that front end needs, and it sends it to them. The only trouble here is that this is a really good service to use, but again, I would say this is sort of like a building step. So you wouldn't come from this level where you have one engineer, front end, web app, and a monolith. You wouldn't come from this level directly into the level of a GraphQL server.
Yeah. So it needs to be a bit matured, sort of, to go into that.
It needs to be matured, and it only works for some scenarios. It doesn't work for everything. So a guy who just writes a front-end web app on his own and a backend service and adds a GraphQL to that makes no sense, because you only have one backend service here. So until you come to maybe a stage like this, or a stage where you have backend for frontends, only can you go into something like GraphQL. And instead of this, what I would basically say is GraphQL, right now, GraphQL is sort of like a alternative to backend for frontends. So I would class this here. So if you take this guy, and this guy, this would sort of be like the progression. Sorry, this guy would come here. This guy would come here. Okay, there you go. So once you progress from there, you have the option of either going for web backend for frontends or for going for GraphQL. So either the BF pattern or the GraphQL pattern. So I'll just call this a pattern. I don't know if it's actually a pattern or not, but yeah, for the sake of simplicity, we can call it that. Sorry. Okay, yes. Now, similar to having distributed BFFs, we can also have distributed GraphQLs. But this is, again, depends. This is, when I say large teams, these are like teams with more than maybe 500 engineers. It depends on, it completely depends on your use case. It completely depends on how big your team is and the troubles and the problems that you guys are facing. So instead of having one GraphQL server like this, Netflix introduced a pattern called federated GraphQL, which is basically a bit more, it's kind of like this. It's a bit like this, but you have a bunch of other stuff in here. It distributes GraphQL, the server, into domain-specific stuff. So as I talked here, like that's really important, knowing about domains. So it only makes sense if you are in an organization, an engineering organization that is big enough to have a lot of domains and a lot of engineering teams, each to its, basically something like each to its own domain. You might have organizations where you have a single domain and a bunch of engineering teams under each of those domains. But then again, most of the time what's out there is you have each team looking into its own domain. So yeah, so if we talk about the Netflix pattern, so I'll just go into here.
So I think maybe that's our main topic, I guess. The discussion would be going around the Netflix
Exactly.
GraphQL, federated GraphQL.
Federated GraphQL. So I'll just call this a Netflix pattern. And what this means is this is domain GraphQL services and federation. Okay, so what you would basically have here is you would have stuff like this, but a bit back. Okay. And instead of this, what you would have is something called a federated GraphQL server. So you would have a big, it's really not big, but to get the idea, federated GraphQL, and this would be a dashboard DGS domain graph service.
So each of the backend BFF would be another GraphQL service, right?
Yeah, so it's not really a graph. So you would have, instead of having one giant GraphQL server, you would divide this up into domains and give it to those separate teams. So
Yeah.
for example, the dashboard Microfrontend, they would have the dashboard domain graph service. Profile guys would have the profile DGS, order would have the order DGS, auth would have this and that. This only makes sense again if you have a lot of microservices and a really huge team. So here, what would basically happen is I would not call this order service, I'll call this order domain. Okay, this is just one example. So I'm just going to leave this blank. If I'm going to draw all this, it will take a long time. So imagine the rest of it looks like this. So you would have the order domain. Okay, so this would be something like let me see. Yeah, so this would something be like the order domain. This guy would have the order service. This guy would have the something else called maybe the order reminder service. Okay, he would have something called the order tracking service. He would have another thing, maybe order event service. There's some sort of eventing stuff. You would have an order scheduling service. These are just random names that I'm bringing up here. But what these would basically do is these would directly point, these belong to the order domain. And these would directly be, hold on. These would directly be connected to the order service there. So that there comes down. Yeah. This guy would point here. This guy would come here. This guy would come here. So this is sort of what a domain is like. So each domain would have a bunch of these services under it. So it makes sense to maintain all these services under one domain because they are all related to ordering. So for example, you're on the orders page of some sort of e-commerce site, and you want to maybe fetch some orders, but what your front end would do is it would hit the federated GraphQL. This would, based on the query, it would look up and it would decide, okay, this is a query that needs to go to the order DGS, the order domain graph service. And that would actually be the guy who would be serving all of these other microservices. So this, again, this only makes sense if you have a huge amount of microservices, or not even microservices, even event-driven, even, I don't know, nano services. I think there's a term, right? Nano services. It doesn't matter if you have a lot of services in your backend, and all of those services can be clearly defined into domains. then yes, then this Netflix pattern makes sense. I still don't know. The only company I know of that has implemented federation is Netflix. I don't think any other company has gone this route because this is a very drastic change. So, but this gives you a lot of flexibility. So what happens here is each of these domain graph services are actually maintained by these teams. So what I would call here the order domain. Let me see if I can bring this forward. Maybe you can fill this. Yeah, okay. Yeah, that makes sense. So order domain, this would basically be something like order domain / team. Okay.
Yeah, for example, that team might be having like 100 members. So it should
Exactly.
be a large.
That team
Yeah.
would have a huge amount of members, or it might even be a single team. No one knows. It depends on how your organization is structured. But the key point here is that this team would be managing its own GraphQL server. So it doesn't make sense for a very small team. So maybe you have three engineers and only one microservice. It won't make sense for you to have your own domain graph service. It would make more sense for you to go in this pattern, which would be one single GraphQL server for everything, because you only have just one microservice. As your team expands, as your team grows, as you introduce more microservices, it will be a mess to try and maintain the schemas on this GraphQL server, which is why we have these domain graph services. So each of these services have their own schema. So they have their own schemas and types. So this guy has his own schema.
Is there a global schema which we keep in federated GraphQL?
Yes, there is. So what happens is you have this schema here. Whenever you publish a new schema, what happens is the federated GraphQL would fetch, you would basically publish that. The federated GraphQL has another service, which would take the schema, it would validate it, it would make sure that it's backwards compatible. And if it's successful, it would apply it to its own schema. So this guy would contain basically the schema. He would be like the god of schemas. He would have the schema. He would have this universal schema,
like master
schema built up of all of these other stuff.
Yeah.
So that's what the federated GraphQL would look like.
Yeah, that makes sense now, I guess. Yeah.
Yeah. So, but again, this pattern of going for domain graph services and federation is only, I would say it would only be advisable if you have a huge engineering team.
Yeah, otherwise it's over engineering.
This is complete over engineering unless you have that problem. So I have been in organizations where even having these sort of stuff. So for example, let me just zoom out. These two guys could become a monolith, basically. This GraphQL server and this backend-for-frontend could become monoliths. In order to prevent that from happening, and in order to basically distribute all these functionality between the different domains and between the different teams, only would you come up with something like federation. So I would say federated GraphQL pattern is sort of a replacement for the BFF pattern for large teams. So basically each team having its own BFF.
All right, yeah. And if we sort of go into some use cases, Damien, like let's say, okay, we have a clear cut. Netflix is our sort of the introducing party here, I guess. So for example, if I have a, let's say, expert, let's say it's not a large team, let's assume it's a small team, but we want to, like, let's say we need XYZ features, as in not features, I'd say one would be scalability, one would be reliability. So where does this federated architecture we can plug in, like which ticks would it basically?
It would have
all of them.
It's scalable, it has everything. So you don't really have, so all of these architectures other than Monolith is scalable.
Yeah, no, so I'd say, like, let's say, when would the company know we need to get out of this architecture and go into DGS?
They would know that when they are okay, so say I have my product owner gives me a feature and says, okay, I need this out by next week. Okay, this is an important feature. The client's asking for this. we need this out by next week. Our users say that they can't live without this feature. I say, okay, and I develop the feature, it's all ready, but then I have to wait 2 weeks to deploy it. Why? Because it's
in the core system.
So I'm waiting for my schema to be applied, because either we have release roadblocks. So either the company, the release strategy, strategy says that, okay, we release every week. And because of that, I had to wait until the weekly release for me to merge my changes and push it forward. Or maybe somebody has gone and they have screwed up the main GraphQL server, and we can't push any changes onto that. Or maybe there would be another case where, okay, I start to get a lot of problems with conflicts. So merge conflicts in using Git. So every time I try to do a change to a schema or something like that, I find out that some guy from another team has come in and touched that schema that I was trying to edit, and I had to resolve that. Once I resolved that, immediately the next second, another guy has come and merged this, and I had to resolve that. And it would be a nightmare. So when this is about developer experience. This is not about performance. This is not about anything related to the front end or the back end or anything like that. This is completely about developer experience. So it's in order to make the developer self-sufficient, and in order to make him sort of the master of his own code. So basically what this would enable is whenever you do a change, maybe to an endpoint in your order service, and you do the change on your schema, on your DGS schema, so that's here, and you publish it, you are not basically blocked by anyone from any other team. So this is very common in organizations, engineering organizations with maybe 100 to 150 to 200 people, because you always find that you are fighting with another person to get your code deployed.
Yeah.
So it's very difficult. So
it's
either you have to wait out. Yeah.
It's like a very developer friendly sort of, like when you have a massive team. Yeah.
Exactly.
You can't plan those sort of things in a like if it's a 1,000-member team, you can't plan much.
Exactly. You cannot expect. So maybe it's not just a 1,000-member team. Maybe your engineering team is spread across the globe. So you have people in Scotland, Germany, Sri Lanka, USA, Canada, all working in different time zones, all doing different stuff. So you can't expect everybody to coordinate and get everything done together. It just won't happen. So this is again one of the ways in which you can solve that. So I would say, to answer your question, when would a company know when to switch to the Netflix pattern? So domain graph services and federation, they would know because the engineers would get fed up of the way that they had to deploy and the way that they had to manage. So the feedback would come from their own engineers. Okay, it's time that we change this up and we switch to maybe GraphQL. As and when your team gets even more bigger, these two will become a big pain point, because these two would start to behave like monoliths. The same problems that you had in your organization with monoliths, you would start to face here. So in order to avoid that, you would have these two patterns. Either the BFF pattern for large teams, which is basically you have BFFs distributed across different domains, or you would have this pattern that Netflix brought in called DGS, domain graph services.
I think we'll share those links as well. Where I think there are 2 links, right? Netflix added with their sort of the case study, and
exactly.
Yeah, with the discussion we have, I'll say one key factor, like it's a thought which I have. So as you said earlier, like it's like a continuous process. You have to come step by step if you're going into this. So that's actually like might block most of companies going into that directly. So if they might be on the second stage and they think they need the last pattern, like the Netflix pattern.
That doesn't work, no.
Yeah. So I'd say it's a very like need some very perfect planning if you're going into this sort of thing.
That's quite true. So normally, but in my experience, what I've seen is always 99% of the companies start like this. Have one engineer working on something like this. It gets a bit bigger until you come to a point like this. So either the first BFF pattern or the second GraphQL pattern. So you would basically come to a point like this, but it's very rare for people to actually opt for something like federation, because it would be a nightmare initially to set it up as well, because coming from something like this and trying to set up something like this is very hard. Or maybe coming from Monolith and doing this, because personally, I have worked on Monolith deprecation projects before as well. It takes a very long time to come from this model to this model itself.
Yeah,
the
it's a
model
whole migration.
kind of like this. Exactly. This entire migration is very hard. So it can.
And you might end up having all stuff as well.
Exactly. So sometimes you cannot actually 100% deprecate monoliths as well. So maybe you can deprecate it to maybe 90%, but you still have some sort of code that you need to live still as a monolith within that monolith. So then that monolith would ideally be transformed into a microservice. It would not stay on as a monolith. It would instead be transformed into a microservice. So it would just evolve into a microservice there. But this process, going from startup model number 3 to startup model number 4, I have seen people do it within 8 months. I have seen people take 3-4 years to do it. I wouldn't say 3-4 years, maybe 2-3 years to do it. So it's very, very hard. So normally what happens is, because people see that, okay, this is not really viable, dashboards directly connecting to these microservices, or these microfrontends directly connecting to these microservices, they directly go to a pattern like this, which is also completely fine, because you already have your microfrontends and your clients as well as your microservices already in the play. So another point for GraphQL is, say that you want to maybe have a public facing API for some of your clients API. So maybe you have some sort of I don't know who are the people who provide public APIs. So you could have some sort of enterprise application.
Let's say Zoom.
Does Zoom have a public API? Do you know that?
Yeah. Public as in, we can get the APIs and do everything.
So, so Zoom has a public API. Okay, so it would be much easier to plug that those clients directly into a GraphQL service here, because they won't have visibility into how your backend actually works. They just know that, okay, this, I request this, I get this back. Completely fine. And also another great thing is that GraphQL, it checks that the types that you have specified, type checking is there. So it checks that whatever is sent from your service, microservice, is actually checked. So it sort of acts as a contract checker there. So that's really cool in that sense.
All right. Yeah, I think we sort of discuss a lot in the GraphQL space and the what do you call, the Netflix pattern.
Exactly.
And so I think let's share some thoughts, David. I mean, like anything, like let's say GraphQL, BFF, Netflix pattern, like DGX based method. One of the the key issue I faced early is, like, I tried GraphQL earlier back in the days, but I face a lot of issues because, like, most of the services were beta and sort of changing every week or so. So I don't have a very positive experience yet. I think I am yet to experience the sort of the best part of GraphQL. What about you? What do you think of practically using it out there?
Practically using GraphQL, I would say that it's good. So as a person who has used BFFs in the past as well a lot, using Graph and having used GraphQLs as well, GraphQL services, I would say both are really awesome, but again, both depend on what exactly you want to do. So GraphQL would be overkill for some stuff. It would be perfectly suitable for others. Your experience depends on what you're actually trying to do there. So for example, if I have maybe only 5 people in my team and I just implement a GraphQL server, it would make sense. I only have 5 people with 2 microservices with a GraphQL server. It does not make sense at all, because you have to go and you have to maintain the schemas, you have to do all that jazz. It would be much more easier for us just to write a BFF in Node.js or something like that. It would be horrible to maintain something like a GraphQL server among 5 people with a lot of stuff to deliver, with a very tight deadlines and stuff like that. So it all depends on your use cases and where exactly you use those. For
Sure.
if places where I have used them, thankfully, the people who decided on using GraphQL did a good job and they took the correct decisions. I have used both GraphQL and, sorry, I'll just add this here. I have used both GraphQL and BFF, so both were selected for the correct place for the correct job, and yeah, I would say it entirely depends on the use case there.
Yeah, and yeah, just to share one thought, like one of the key, not a mistake, like a misconception is when we say GraphQL, usually people tend to get graph databases. So earlier, like when it wasn't like this sort of a practical, I mean like practical use. So I think like that's one of the misconceptions we need to clear as well. Like GraphQL is not graph database, so it's a completely
No.
different thing.
Yes.
Yeah, I think that confusion came with Facebook Graph API, I guess, or
Graph
something like
API,
that.
yeah, I remember that. Yeah.
Yeah, so things like that are very like open, and we sometimes don't see them. So be careful, guys.
Exactly.
Yeah, I think Damon, what about our, let's say, our usual like alternatives? Do you think any alternative for Netflix pattern, like any
Yeah, that
recommendation,
would
or this
be
is sort of the best?
no. This is not the best at all.
Yeah.
It would not work for a lot of companies out there. I would not recommend it unless I had a lot of resources and a lot of manpower to actually implement this. Because
Yeah.
you would need to train your engineering team. You would need to make sure that this actually works properly, that everything is actually set up properly, all your pipelines are properly set up, your schemas are getting migrated properly, backwards compatibility is properly being maintained. You have to have tests for that, integration tests, end-to-end tests. It will become a nightmare if you try to implement this if you are not ready, unless you have all those other building blocks with you. So I would not recommend this for
Mainly for
everyone.
yeah, production level application. Like I think even Netflix, they didn't fully went on it at first. They went in for like a smaller like Netflix Studio or something like that, and then
Exactly, yeah.
adapted the solutions and the framework and everything came with that. So I think that's a good learning, as in like don't just jump into this one and
Exactly. So
so, yeah.
you have to have a lot of stuff in place. So one thing I see is it's easier for us to actually add all these on if we know that, if we are 100% sure that it won't affect the final end user experience.
Yeah.
So you have to have browser monitoring in place, synthetic tests, integration tests, end-to-end tests, unit tests. You have to have every test under the sun to make sure that nothing, performance tests, that nothing actually affects
Breaks.
and breaks any of your users' experiences, because this is strictly, again, I'm saying this like very specifically, this is for developer experience. This is not for anything else. I mean, yes, having federation, having GraphQL services, having DGSs, it also helps you to achieve your business objectives much more faster. It also helps you to make sure your engineering teams are independent. It has a lot of benefits like that. But personally, what I would say is, as a backend engineer, what I see in myself is that this is basically developer experience here. So we need to make sure that user experience is not affected when you implement something like this. So you have to have a very sound sort of infrastructure already in place before you try to push something like this into the existing landscape, into the existing infrastructure of your organization.
Yeah, that's a good thought. So shall we, I mean, wrap it up as in like go from top to bottom once again, just quickly, as in like what we discussed. I think we like the diagrams are very good, Damien. Like it gives a lot of sense, and we can even share the link, maybe like a or PDF even with the viewers if they need to look into in depth.
Exactly.
So we'll just go from top to bottom and just then end up with Netflix federated, and like because that's our discussion topic
Exactly.
today.
So in order to understand why we need Netflix Federation or why an organization would choose it, we need to first understand how organizations start, or engineering organizations actually start. So you would have a bunch of people in startup, you would have marketing teams, sales teams, and all this stuff. But ideally, normally what happens is you only have one engineer who's doing the front end, the back end, and everything in the middle together, the infrastructure and everything together. So that would kind of be startup model number one. And as your startup grows and grows, you would start to accumulate more engineers. You would start to add more client applications, so need mobile apps. plus your existing front-end app, but you would probably still be working on your existing monolith. Again, as more and more engineers grow, now you start to come to a point where your monolith is becoming a bottleneck, and your engineers are basically cursing each other and saying, okay, look, I can't work like this anymore. We need to break this up into separate, smaller, focused or scoped services. And that is basically where the microservice sort of pattern comes in, where you replace the monolith with a bunch of microservices. While you replace a bunch of these microservices for the benefit of the backend engineer, so I just made a leap here and I went for the microfrontend pattern. Your front-end engineers would say, okay, look, I can't work with that guy who's in that team working on this code base and this common code base here. We need to split up the web app also into different domains. So then you would go into the micro front-end sort of architecture. But once it comes to this point, you start to realize, okay, it doesn't make sense for each micro front-end to directly consume any of these services here. So normally we would have another step in the middle here, which would be an API gateway for each of these dashboard or for each of these clients to access the backend. Because this is basically not a pattern that you would ideally see in production, startup model number 4. Once that is done, once you have maybe your micro front ends and your microservices in place, you would come to a point where you need to basically aggregate your data. You need to transform your data. You need to do stuff like protocol translation, maybe, and all these different orchestration stuff. So then you have the choice of either going for web backend for frontends, BFFs, or for GraphQL service. I will keep this out of this discussion because that is just an additional note. And basically, both of these behave kind of like the same. The only difference is that with backend BFFs, backend frontends, you would be writing all that code yourself. You would be writing your service classes, your controllers, and all that stuff. Whereas with GraphQL, it's sort of like a very simple framework which you can implement, which does type checking for you and maintains this complete schema. And it also does transformations, it does aggregations for your front-end engineers. One important point here is that it exposes endpoints for your front-end engineers so that they can transform the services in any way that they want. So these payloads, So for example, in BFFs, you would have fixed endpoints. So for example, you would have an endpoint that returns data from user service, order service, and payment service. But if you wanted to aggregate the data from payment service and login service, you would need to implement a new endpoint. That doesn't need to happen in GraphQL. If your front-end engineer needs data from all services at once, you can still request that, depending on whatever pattern he wants and depending on the schema. As your team grows bigger and bigger, you might want to look into the BFF pattern for larger teams, as well as the Netflix pattern for GraphQL. So the BFF pattern for larger teams, as well as the Netflix pattern, depends on domains. So domains are basically sort of scoped business level teams. So for example, if you have an e-commerce organization, you would have the ordering domain, you would have the user domain, the payment domain, and domains like that. So basically engineering units and business units that are solely responsible only for whatever that part of that function of that application. So as and when you go into these domain specific stuff, you would need to, in order to make your developers' life easier and in order to reduce complexity and scale everything out and basically have separation of concerns, you would either go into the BFF pattern for large teams, or you would go into the domain graph service and federation pattern, which we have called the Netflix pattern here as well. So these two patterns are derived from the pattern on top. So instead of having one single BFF, you would have a bunch of different BFFs for each domain. Similar to that, instead of having one gigantic GraphQL server, you would have domain level GraphQL servers. And each of these domain level GraphQL servers would be connected to a federated GraphQL server, which would maintain sort of like the universal schema for all of these DGSs, these domain graph services. So yeah, That's about it. And basically what happens
So
here, the only reason you go into this is depending on your business objectives, your OKRs, as well as your whatever requirements your business actually has.
yeah, so continuing from that, I mean, the idea of like this is more like giving the engineers experience, like it's not like a very architectural like benefits. We are looking at like a developer experience, so that's a good point to have here. And then the idea we discussed where what do you call, we need to be very sure if we are moving to some architecture like Netflix pattern, because it's very huge and gigantic, and it's not easy to move from the above methods and just go into that. So yeah, I think those 2 points would be a very
Exactly. So
insightful.
this is actually a journey, a journey from start to end. Instead of actually, you can't just wake up one day and decide, okay, your entire organization needs to have the DGS pattern in it. It's just not possible. It takes a long time. You have to do proof of concepts. You have to make sure that your organization is verified. You have to make sure your developers are okay with it. Because again, this is completely, in my perspective, as an engineer, as a software engineer working in the backend, this is entirely developer experience and nothing more than that. It helps in the organization level. I mean, a project manager would say that this is actually an organization level thing where you need to divide domains and stuff like that. But when you get to the truth of the matter, this was a pattern that was developed by engineers for engineers. It doesn't make sense for anything else. Yeah.
I think with that note, we can wrap it up for today's discussion.
Exactly.
All right. So thank you guys for coming today and watching our videos again. We'll catch you guys in the next one.
All right. Thanks, guys. Cheers.
Thank you. Bye.